Hello and welcome back to the Minecraft Multiplatform modding series with Architectury, and in this episode I'm going to show you how we can make our Ruby ore, which we've added before, generate naturally in the world so that we can find it underground and mine it. Now, the way Minecraft does ore generation, and for that matter also every other type of generation during the world creation process, is through the biome files. So in the Minecraft data folder there are the biome definitions, and I've opened here the plains.json file of Minecraft Vanilla. So this is the default definition for the plains biome, and as you can see we have here this features block, and in here we have multiple lists of strings, and each of those strings is a key that indicates one feature that can appear in a world, and those keys are here grouped in different blocks. So this, for example, is the ore group. So every block here, every one of those keys indicates a type of ore or underground ore-like structure that can generate during the world generation. For example, here the ore iron upper, ore iron middle, ore iron small. Those are the different kinds of iron ore groupings that can spawn in a world, and you can see this for all the other ores here as well. And below that, here are also the different things like water, lava sources, vegetation generation, and down below here are then the entity spawns, but we'll be not talking about that today. Today we're focusing on the ores. Now, if you would want our ore to generate, the simplest way essentially would be to just copy each of those biome definition files and overwrite them in our data pack. But the problem with that would be that this would make our mod entirely incompatible to any other mod, because we overwrite the default biome definitions, and if another mod modifies them as well, we would overwrite those modifications as well. And also, every time we would need to update the game, we would need to check if anything in the vanilla file changed and then copy those changes over. So that's not a very efficient process, and it's also not a very practical process, because as you can see there are a lot of different biomes, and we would need to add or to pretty much all of those files if we wanted it to generate everywhere. So instead we need to use the mod loader provided methods of adding things to those files during the runtime. And NeoForge does this through JSON files, and Fabric provides us with a method that we can call on the mod initialization to add a feature to the world generation process. Again, we need to do this individually for both mod loaders, but there is a part that we need in both cases, and this is essentially what is defined in this biome file right here. So Minecraft _redstone, for example, does not correspond to a redstone ore block. Instead, it corresponds to a placed feature. And a placed feature tells the game how to generate a configured feature inside of each chunk. And a configured feature, on the other hand, tells the game how to generate a block, for example, what we do, an ore block in a grouping. And then the placed feature tells the game how to spawn those grouping in each chunk. We add that placed feature to it. And those two definitions we need in both cases, so we can create them in our common project or common submodule. So let's go there and go into our data folder and then in our mod ID folder. And here we want to create a new directory and call this world gen, and then configured _ feature. And we also want to create a second directory, world gen, and then placed _ feature. Now let's start with the configured feature. I've prepared the corresponding file, and this is an example of how this may look like. Now what we define is in the top here that we want an ore feature. So an ore feature is something that can generate underground, like any ore, as the name suggests. And then we configure here the parameters of this feature. So the first part here is discard chance on air exposure, and this means that if the block we want to spawn is exposed to air. So if it appears, for example, in the cave wall, this is the chance that this spawn is then discarded. So in this case, a 50% chance that a block that would be in the side of a cave wall would not generate if it is exposed to air. If it is completely surrounded by other blocks, this is ignored simply. Next, we define the size, and the size is how many attempts to spawn a block are taken when this feature is spawned in the world. And how they are grouped again is decided by the OR type, so they are not just clumped together, they are a little bit spread out depending on what Minecraft decided in this OR type up here. And the next part is that we define the targets. And the targets are the blocks that this feature contains. And every time the game tries to generate one of those blocks, it checks every single target if there's a matching one, and if it finds a matching target, it does the generation. So in this case, we have two targets because we have a regular Ruby OR block and we have a deep slate Ruby OR block. And the first one, we define in the state the name, and this name is the block we want to generate, in our case the Ruby OR. And down below in the second target here, we have the deep slate Ruby OR. And then we have a target below that, and this specifies which block we try to replace when generating the OR. In case of the regular Ruby OR, we want to match the tag Minecraft stone OR replaceables. And every block that is listed in this tag is a block that in vanilla can be replaced by a regular OR. So a regular iron ore, a regular coal ore, etc. all use this tag for their regular counterpart to generate on. And for deep slate, we then use the deep slate OR replaceables. And this makes then sure that if there would be a deep slate block, we would generate the deep slate OR, and if there would be a regular block, we would generate the regular OR. Now, this gives us the configured feature, but this does not tell the game where exactly to generate. It just tells what to generate. So now we want to create a placed feature which tells the game how to generate this feature inside of the world. And I've also prepared this file. And this looks like this. So the first thing we define here is the feature which we defined above. And then we have the placement block. And this now defines how the game should generate this. And important is that this is applied per chunk. So this is executed for every single chunk. And so for example, if in this case we say that the count is 3, that means that there are 3 attempts to generate a Ruby OR cluster in each chunk. And down below here, we then also define the height range. And this tells the game in which heights or depths, in this case, is more fitting of a word, the OR should generate. And uniform means that we have a uniform distribution. And we define then here our upper and lower bounds, in our case 20 as the upper bound and the bottom of the world minus 64 as the lower bound. So that means that between those heights, a generation of a Ruby OR is possible, but that's entirely up to the random algorithm that's executed on world generation. So all of the 3 clusters that are attempted to spawn in one chunk may be at the top or at the bottom, but statistically they are more likely to appear in the middle. And down below here we say that this feature is then linked to a biome. And this is what we now need to do. We need to link this feature to biomes so that the OR can actually generate in the world. So for Fabric, we simply head to the place where our onInitialize method is, and then Fabric provides us with the biome modifications class. And in here we have essentially 4 methods. We have the add feature, which we'll be using today, which you can use to simply add a feature to a biome, such as an OR, for example, like we will be doing now. Then we have the add carver, which is used to tell the game how the landscape should be carved, as the name suggests. Add spawn is to add mob spawns, and with the create we can create an object for a specific set of biomes, and this then allows us to go into even more detail, like removing vanilla generation features or vanilla spawns, but we'll not be covering this today. Today we just want to add a simple feature, so we choose the add feature method, and then we need first a predicate for the biome selection context, and this states which biomes should be affected by this modification. And Fabric provides us with a few standard options for this. So biome selectors, and then here we have a few different methods that we can simply use so that we don't have to tell the game, for example, this and this and this and this and this biome. In our case, we use the found in overworld predicate here because we want our Ruby auto generate everywhere, but you could also use, for example, tag and then provide a tag and then create a tag file where you can tag a set of biomes, or you can use the include by key and then select a few biomes manually, or you can use exclude by key that applies then to all biomes except those you specify all. That means then that in every biome across all dimensions this feature would be added, but in our case we just want it to appear in the overworld, so we use the found in overworld. Next, we need to specify which step of the generation process this feature should apply to. So for this, we have the generation step dot decoration, and in here we have the different generation steps. So as you remember in the beginning, we had this different arrays in our features list, and each of those arrays corresponds to one of those steps. And in our case, we want an underground ORs. We want the underground ORs decoration step here because we specified in our, if we go back in our configured feature, that we have the OR type here, and this matches with the underground ORs generation step. And last but not least, we need to create a resource key that references our placed feature. And for this, we can use resource key.create. And here we need first the registry key, and this is registries.placed feature, because we want to refer to the placed feature registry, which this is a part of then. And then we need, as always, to provide a resource location where to find the corresponding file. So we need the from namespace and path, and then specify first our mod ID, and then the name of our placed feature, in our case, or_Ruby. And that is everything we need to do to add a feature, a placed feature, to the world, to a set of biomes in Fabric. NeoForge does this a little bit differently, because NeoForge does this via JSON files. So in NeoForge, we need to create inside of our resources folder a new directory called data, then our mod ID, tutorial_mod, and then NeoForge, and then biome_modifier. And in this directory, we then create essentially a JSON file that specifies everything we've specified in this add feature block here. In our case, we create a file, call it add ruby_or.json. The name of this file is not really relevant. That is just an internal identifier then that is used inside of the game code, but you can name this file any way you want. It is loaded automatically since it's in this NeoForge folder here. And inside of this file, we want to place this. And here the first line specifies that the type is add features. So this corresponds essentially to this add feature we call here in the beginning. Next, we specify in here biomes. And here we have this hashtag symbol at the beginning. And this means that this is a tag and not a singular biome. In this case, the Minecraft is overworld tag. And this is similar to every biome that you get with the biome selectors .found in overworld here. Next, again, we specify in the bottom here the step, in this case underground_ors, and this is the generation step we specify here. And this resource key we specified in the end is specified here through this feature tutorial_mod or_Ruby. This is the resource key in the back here. So as you can see, essentially those two methods specify the same parameters, just in a different way, one time via JSON file and one time via one line of code. But that is everything we need to add our OR blocks to generate in the world. So let's launch the game and create a new world and check if we can find our Ruby OR. With that, welcome to Fabric, and if we go to single player and create new world and then choose the creative mode and generate a new world and wait until the game is finished generating it, we then can hop underground, go a bit down, find a cave. Let me quickly give myself night vision. And then if we fly around this cave a little bit, we may find this is redstone ore. This is also redstone ore. This is also redstone ore. This here, we find our deep slate ruby ore. A little bit hidden here, and as you can see, it generated in the world. If we find another cave, for example, here we may also find one here. As you know, it's slightly less likely that it generates in the open air than behind blocks, but here, as you can see, again, deep slate ruby ore generated here. So yeah, as you can see in Fabric, our ruby ore generates. So let's check if the same is true for NeoForge. So with that, let's do the same in NeoForge, create a new world, choose the creative mode and let the game generate it. And then finally enough, we also spawn in the snow biome. Effect, give dev night vision infinite 1 true. Give me some night vision, and then we again can go underground and see if we can find our ruby ore somewhere. For example, here we find our deep slate ruby ore, and again, as you can see here, in this case we have multiple at the same place. And yeah, as you can see, it also generates here. And with that, you know how to generate your own ore blocks underground. And in the next episode, I'm going to talk a little bit more about entities and also show you then in a bit how we can modify actually Minecraft code. So things that are inside of the Minecraft vanilla game code that we may want to modify. But that's in the next episodes. See you then. Goodbye.